Hello guys, welcome back. My name is IT Guy Michael and I'm glad you joined this video. This is another lecture of the course for Python classification where I show you how to classify a dataset for HR. Now we are going to predict whether an employee will leave the company or not, as I mentioned in the previous video. Now let's go to the first step of the whole machine learning or the predictive cycle. And the first step is always an exploratory analysis. Now, we already did the first part of this in the previous video where we were looking at the columns and the structure of the dataset and stuff like this. But now I want to show you just some code which is used for deeper exploratory analysis. Yes? So let's jump right back into the Jupyter Lab, and as you can see I have here the first file which is called the exploratory analysis. So here is the code. I highly recommend you to write the code on your own. So just stop the video if I'm going too fast, but please don't copy paste the code from the Git. You will not learn anything. You need to learn the syntax. You need to get the code inside your fingers, inside your head, through your fingers and stuff like this. Yeah, you cannot just copy paste it and then you will just end up being this kind of data scientist who is just copying pasting everything from the internet. Well, whatsoever. I just put it here before because while you are developing, there are a lot of errors. I just want you to think about me that I'm not making any errors, but you know what, I do a lot, right? So let's go here. So first of all, compared to the other courses, as you can see, we're gonna use a lot of libraries, a lot of stuff, right? So in the GitHub, you can find the requirements.txt file with all the libraries which I'm using and the versions of them. So feel free to install them with the pip install that, I think it's the app.r/r requirements.txt. Okay, so let's jump here. So we're gonna use pandas for data processing, the NumPy for data processing, the Seaborn. Now the Seaborn is a library which helps you to plot data. Now there is also a matplotlib library. Those of you who don't know matplotlib, you just can copy paste the commands. Matplotlib is cool, but Seaborn is Seaborn is built upon the matplotlib, and to me it's more like nice, more beautiful graphs you can print with the Seaborn. But it's up to you. Then you also need to put here the matplotlib, and I'm also importing the matplotlib, don't know why. Yeah, because I'm setting it here. Now this is just a setup for the matplotlib. So I'm saying how big should be the images presented in this Jupyter notebook. I'm saying what is the size of the font here. So you just can copy paste it. This is nothing important. This is no big stuff. You can find this on the Stack Overflow and copy paste it. Whatever. So first of all, we are reading the data frame with the read CSV, and I'm reading the general data CSV, and I'm setting the employee ID as the index column. So if you look here, and this is the general data, and here you can see there is a lot of stuff, and I'm setting this employee ID, which is a unique column, as an index. This can be very helpful because I don't want to have this this column as a feature, so I'm setting it as index. So it makes me more easy to work with the data later. So, and then I'm dropping these two columns, standard hours and employee count, which makes no sense. These columns are just filled with the same values. They don't give any value to our data set, right? How do I know it? Because I looked into the data in the previous part. Yeah, so when I look here and I saw that standard hours of work for the employee, this is just the same number for everyone. That's the number of hours the worker should work during the day, and everyone was working the same hours. Why? How do I know it? I look into the data, right? And that's it. So I think even if you like look here and find the standard, it's not here. Never mind, it's not here. Okay, so I dropped the columns, right? And then you can see we have about 4,410 rows and 21 columns. We can also look at the PDF head just to show you how does the dataset look like. Yeah, we had here the text data, the categorical data, yeah, the numerical data and stuff like this. Now, the thing I always like to do is just splitting the columns to numerical and categorical data. How do you know it? So if you put a method which is called dtypes here, it's a parameter, yeah, it outputs this is a pandas series, and the index is the name of the column, and the value is the specific data type of the column. As you can see, this is the integer 64-bit. Then there are the objects. These are the the categorical data, and then there is the float 64 for the float points. Now I'm splitting it into like numerical columns, which is everything, not the object. You can just notice the syntax. I'm accessing the D types, which is this series, and I'm setting the D types. This will return a series of booleans, and then you can access them. If you have trouble like sub-selecting data frames and working with data frames, I highly recommend my another course at the Skillshare. Go there. It's a pandas data course. I don't know, there are just 9 students, but this is the greatest course which I ever did so far. So please consider watching the course before moving here. Now then I'm accessing the index, right? And then, why? Because I would like to know just the names of the columns, and then I'm accessing the values because the index will return some strange array. I just want to have the list, right? So this will return a list. I'm transferring it to list. And then I'm adding here the attrition, which is the target variable, which is not integer, but I want to have it in my columns because I don't know why. I will add it and use it later. Now the categorical columns are the object ones, and now the next thing is, it's always a good part of the exploratory analysis is just I'm showing you how you can convert the target variable, if it's a categorical value, into a numerical one. So the problem with this is this one. So if I run this, and then if I go here and I put here the df, let's say numeric, whatever, df numeric, df, oh my god, numeric, and let's say we want the attrition, right? And you can see this is a categorical value. Why? Because I transferred it with the as type category now. And now what I can do is I can access the categorical part of it, and I can access the codes. And now this will encode the true for or 1, and or the yes for 1 and no for 0 or otherwise, right? But I think it's just based on the, yes, so yes is 1 and no is 0. Luckily, always check it out. Sometimes it can be like reversed. No, yeah, because there is no logic. There are just the strings. Now, so this is the way how I'm encoding the categorical values into the numerical ones. Now I'm removing the NA values. Well, why am I doing that? The empty values or non-values inside your data frame can cause you a lot of troubles. I was talking about this in the previous course. So this is just the way how I'm deleting it, the same way as I did in the previous course. So I'm asking if it's not an A, and if the whole so if there is a row with these, then just delete it, and then as you can see, the shape just changed from 4000, from, let's get the shape here, 4410 to 4382, right? So deleted some of the rows. Now, next thing which is important during the exploratory analysis is just to look on the correlation between the attrition, so the target value which we want to predict, and all the other features. Now you can do it because we transferred the categorical type into the numerical. If this was a categorical type, you are still not able to do this. Now please beware that transferring this into codes makes sense only if you want a binary classification. Now we will talk about the classification in the next video and what is a classification and what we're gonna do. But right now the intuition is like we are going to predict based on some employee data whether the employee will leave the company or not. Yes, in the given state. Right. So and how we're gonna accomplish this? We are going to create something which is called a classifier, which is going to be trained on the historical data, and based on this historical data from the previous employees, the classifier is able to say whether the current employee will leave the company or not. Yes? So for this purpose, we are going to use this data. Now, the best use are the numerical data, because how we're going to do it, I will show you later. We're going to use some mathematical functions, which are going to map the behavior of the employee based on the data. And the mathematical functions work best with the numbers. So we are going to use the numbers mostly. But you can use also the categorical data, which we're going to transfer into numerical data, the same way as we transfer the attrition into the numerical data in this line, right? So now because the data frame numeric, so if I put it here, is just composed of the numerical data, I can compute the correlations between each of them, right? So if you remember from the previous video, from previous course, this returns a matrix where is the correlation of each of each rows, but we are interested only in the attrition numeric. And as you can see that the most important features for attrition is the total working years. What does it mean? Because this is a negative number, the less working years there is a higher probability that the employee will leave the company, which makes the sense. There is also the negative correlation between the age and the attrition, and there is also a negative correlation between the years with current manager. So the less years you are with the current manager, then the more likely it is that you will leave the company, right? Which is quite interesting. I don't know, I like my manager and I'm not too long with him. So let's go next. You can also plot these correlations. I really like the plots. They can tell you a lot just based on the picture, right? So how you can plot? So please, this is a very complicated matplotlib command which I just create. I don't know, I copy paste it from the Stack Overflow. Please be sure to copy paste it also, right? So I'm just saying setting x as a numeric, and I'm saying the alpha, well, this is just a variable name, but I'm setting the the axis to the names, and then this beautiful code can create this beautiful plot. And as you can see, we are just interested in this row. So as you can see, there is a very based on the color, there is a very interesting correlation in case of age, which is a little bit dimmer than the gray parts, which are not useful at all, right? But you cannot make any assumptions just based on the correlation. I think 99% of my cases when I was trying to predict something on the dataset, everything was gray, right? And then at the end of the day, I was able to create some classifier. Yes. So please, if everything is gray in your dataset, don't worry. This is just a linear dependency. But sometimes in your data there is a non-linear dependency which you cannot see just with the correlation, right? And there is also a thing correlation is not a causality, and this is a big topic. Go to the Google and Google it, and you can see some funny examples between the correlations in the world, and which are not telling anything about the real world, right? Let's go next. So this was the correlation. The next step of the exploratory analysis is the data distribution. Now, what does it mean, the data distribution? You will see it on the example. So you got as you can see, still I'm working just with the numerical data in these examples. So I'm getting the numerical data from the data frame, and I'm writing a histograms. And as you can see here, you can see the range of the distribution for age. So we have some examples with the guys who are between the years, I think this is 18 up to 60, yes? And most examples here are between 30 and 40, about 35, right? Makes sense. That's valid, right? There are the pensionists after 60 and they are just too young to work before, right? Then this is a distance from home. A lot of people are living very close to the office. I think this is in kilometers, I'm not sure, maybe not. And then some guys are living as far as 30 kilometers away from office, so they need to go to the office at least 1 hour. From the education point of view, there is the three most occurred one, and that was I just tell you, education 3 is a bachelor degree. Well, to my country, bachelor degree is not so often. Then the job level, blah blah blah. And as you can see, there are different ranges, and these graphs are called the distributions. And in data science world or in predictive analysis, the best distribution is the normal distribution. So it looks like this. So everything is the most common part is around the center of the distribution, and then you have this beautiful bell-shaped function, right? So this is good one. And then in most of the real world cases, you will end up with long tail problems. So something like this, you have this big hill and then a long tail of lower values. And we will fix this long tail issue in the pre-processing or the preprocess, yeah, in the preprocessing video, right? As you can see, there are a lot of long tails, or also this is a somehow long tail, and this is a long tail, right? So these long tails can cause troubles to your classifiers. So we will need to like adjust this distribution to be more than normal distribution, so this bell-shaped distribution. Also, as you can see, there are various ranges from the numbers. This is from 0 going up to 60, while this one is going from 0 up to 200,000. 200,000 monthly income. What is this? Well, these guys, some of them are very rich. Well, next. I have something special. This is a pair plot. And now reading a pair plot can be sometimes very tricky. So I will just show you. So this, for example, this one shows you how are the examples distributed between two variables. So the age variable and the years with the current manager. So as you can see, when there is less years with the current manager, and here is the legend, so the orange one are likely to leave, and the 0 so means they are not likely to leave. It's a blue one, and as you can see, there is some linear. So if you can split this graph with just one line and separate a lot of cases on one side and a lot of other cases on the other side, this means there is some visual linear correlation or linear relation between the predicted value and two of the target variables. So as you can see, if we put here the line, we would be able to separate these two guys, right? And also here, so the pair plot can show you the linear dependency between two features and the predicted feature, right? So this can be very helpful. Now, looking into these graphs before you move to some predictions can save you a lot of time. Why? Because you may find that there is not a single linear dependency in your data, and you'll just waste your time with the simple models. You can maybe try some neural networks which can help you, but you know, sometimes without any correlation in the data and any linear dependency, you are just wasting time to make some analysis later. Okay, so this was just like a introduction into exploratory analysis. I showed you some examples how you can look into data to find some correlations, to find some dependencies. Please always consider doing these things before you move to the actual predictions. So guys, thank you very much for watching this lecture. I will see you in the next lecture of this course. Have a nice day.